All right, welcome back, guys. Here's the last lesson of 10.1. So 10.1.3, what we're going to be doing is we're going to be doing a significance test for a difference in proportions. All right, so if you wanted to retitle this, this is us actually doing a significance test from a theoretical perspective for a difference in proportions. So is there enough of a difference in our samples for us to basically find convincing evidence for an alternative hypothesis? And so basically what we're saying is difference in proportions is P sub 1 minus P sub 2, and that's what we're going to be worried about. And so here's what we need to know, and this is kind of the sub-bullet point. We've kind of had a break of these sub-bullet points for a while, but we're going to mention this idea of P hat C. And so basically that means combined. So the C means combined. All right, so the idea is if we make an assumption, there's a problem that's going to exist here. And so this is only true. This isn't true for a confidence interval. This is only true for a significance test. And so we're going to try to address that. But the idea is that we're going to combine two sample proportions. And the main reason why we're going to do that is because we're trying to avoid contradicting the null. And that'll make sense here in a second. Like, why are we going to combine these things? We're going to avoid contradicting the null. So with that, let's get rolling here. So it says, according to this website, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. A certain university, all right, so I guess a university would like to see if this is true for their student population. Let's assume that it's a big university. And so here's what they did. Is they took a random sample of 300 STEM students and found that 12 were Black or Hispanic females. And then they took a separate random sample, so you can see two samples, two proportions, and found that 75 of the 500 non-STEM students were Black or Hispanic females. And so some things that I would go ahead and look at is I would say random, okay, random, perfect. It's going to meet random for both. And then we're going to have this idea of P hat sub 1 is going to equal 12 of the 300. And then we're going to have this P hat sub 2 is going to represent the 75 of the 500. So what we want to do is we want to see, okay, eventually we'll talk about the order of kind of operations here, but is there enough of a difference between those two things for us to be alarmed? All right, so we're going to build, like, what's our assumption? How are we going to build a model for this? And so then notice the question here is it says, do these data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? So I guess if I had to highlight it, this is pretty typically what the question is going to look like. So it's going to say this using a 5% significance level, and then it's just going to be a blank canvas. There's going to be nothing after that. So if I were asked to go through this, here would be my process. So I'd say step number 1, I'm going to state. All right, so here's the state portion. My parameter is I'm going to take P sub 1 minus P sub 2. I have two separate proportions. What does that mean? That means that I'm looking at the true difference, and I'm going to use some shorthand here. True difference in proportions of Black or Hispanic females in STEM and non-STEM programs. And then you'd probably say at this certain university. All right, so maybe I'll write that in here. At this certain university. So we want to see, is that true at this specific one? And so some things to throw out there as per always here is we say STEM is going to be P sub 1 then, and non-STEM would be P sub 2. All right, so this is going to be a perfect example of looking at what happens when we have a negative statistic. And so that's why I'm going to phrase it that way. So our statistic is, let's take P hat sub 1 minus P hat sub 2, and let's look at, okay, what did our sample tell us? All right, so imagine we had 12 of the 300 students represented in STEM were Black or Hispanic females, minus 75 of the 500 were Black or Hispanic females in non-STEM. And so as I look at this here, the difference then is 4% minus 15%, which is a negative 0.11. So 11% more Black and Hispanic females in the non-STEM program versus the STEM program. This gives us some evidence. We have some evidence that the non-STEM program for Black and Hispanic females is outweighing that of the STEM program. And so what we're going to do now is we're going to create our hypotheses. All right, so what is our null hypothesis? H sub O is going to be P sub 1 minus P sub 2 is equal to 0. We're going to assume that there is equal representation, that there's no underrepresentation. And so on your calculator, what that's going to look like is P sub 1 equals P sub 2. All right, so we could add P sub 2 to both sides. We'd say, okay, the proportion of Black or Hispanic females in both scenarios, STEM versus non-STEM, are the same. All right, so in a sense, like we're going to assume equal representation. Now, you don't have to write that necessarily because we defined our parameter, so that's just more so for a side note. But the alternative hypothesis is that going to be if we take P sub 1 minus P sub 2, we got a negative number, meaning that we think that the proportion of Black or Hispanic females in non-STEM exceeds that of those in STEM. All right, so we have an underrepresentation. That's what we'd be saying by this. All right, so on your calculator, you can picture it both ways. This is typically how I write it, but on your calculator, it's going to be written as like basically a P sub 1 on one side and a P sub 2 on the other side. And so here's kind of the interesting part, and I'll wrap this up as we'd say, okay, our significance level, it's default to 5%. It tells us 5%. And then here's what I would suggest that you write in here is I'm going to just draw an arrow to the null. And so what we're doing is we are assuming there is no difference. That's what we're saying here, is we're assuming there is no difference. And as soon as we assume that there is no difference, this is where we have to use a p hat c. All right, so we can't assume that there is no difference, and then when we go to calculate standard deviation, use a difference. So this is going to become a big deal when we start thinking standard deviation. So we can't say that there isn't a difference and then later on contradict ourselves and say, oh, but by the way, there is a difference. We're gonna have to come up with this new calculation, this p hat c calculation, and so just be mindful of that. That'll come full picture here in a second. So as we keep going down this line, what's the name of our procedure? Well, the name of our procedure is that we're going to take two proportions, all right? So STEM, non-STEM, all right? So a two proportion, Z. Now we're going to do a significance test. We're making an assumption and we're seeing how did our negative 0.11 measure up to what's expected if there is no difference. And so this is for P sub 1 minus P sub 2. And then let's check our conditions. All right, so when we check our conditions, random, we took a random sample, 300 STEM. We took a random sample, 500 non-STEM. Check at this specific university. 10% condition, is 300 less than or equal to 1/10 all STEM? Let's assume it's a big university, so let's say yep. And then we'll say 500, is that less than or equal to 1/10 all non-STEM? Big university again, let's say yep, so it meets that. So they're independent enough, we're getting unique enough samples that we don't have to worry about repeats. And then finally, we'll check our normal condition, which is going to be the large counts condition. So imagine if I take my 300 and then I have 0.04 are represented as Black or Hispanic females, did I expect at least 10? Sure I did. 300, 0.96. Is that greater than or equal to 10? Yep. 500, did I expect there was a 15% were Black or Hispanic females? So we'll say, yep, expected at least 10 Black or Hispanic females. Expected at least 10 not Black or Hispanic females. Check. So separately, their distributions are normal. So the STEM distribution, normal. The non-STEM distribution, normal. So when I combine them, I end up with a normal distribution as a result of that combination. So let's go through and let's do this by hand just one time because this is how it's going to show up on the multiple choice. And so the center of my sampling distribution, if I looked at all samples of size 300, where I took the proportion of Black or Hispanic minus all samples of size 500, Black or Hispanic, what's going to end up happening is that it's going to be centered around my assumption. So it's centered at the null. All right, so it's if I assume that there is no difference, then I expect my samples to show no difference. Right? Like that's what should happen. If they're assuming no difference, then when I pull samples, I expect to see no difference or close. Now, you won't have to do it this lengthy on the AP exam or on our test, but the standard deviation, what we have to recognize is that we're going to try to come up with the standard deviation of my sampling distribution. So how much does the difference in proportions typically vary if I looked at many, many samples? And so the way that I would do that is I'm going to take, for our confidence interval, we would take p hat 1 times 1 minus p hat 1. This is what we did on the previous one, all divided by n sub 1, plus p hat 2 times 1 minus p hat 2, all divided by n sub 2. Now, here's the problem with that, is if I look at this, and I'm going to try my best to do this with highlighting it, but what we're saying is basically we're implying that there's a difference in proportions. If we use the proportion from sample 1 and we use the proportion from sample 2, like we're insinuating that there is a difference. We're contradicting our null. And so what I want to write in here, and this is where we're going to be a little bit careful, is that if I did it this way, I am implying that there is a difference in proportions. Which is contradicting the null, all right? We said that we're assuming that they're the same, right? We're giving them the benefit of the doubt. And so if I write them and if I calculate my standard deviation, assuming that they're different, well, that contradicts my assumption that they aren't different. And so this is where enter in p hat c. So p hat c is where we take the number of Black or Hispanic females in the first group plus the number of Black or Hispanic females in the second sample, all divided by the combined sample sizes. So basically what we're saying is it doesn't matter what group you came from, we were going to end up with the same number of Black or Hispanic females regardless. That's our assumption, right? Like that's what we're building. We're not saying that's true, but in this case we would say, okay, we had 12 Black or Hispanics in the STEM, Black or Hispanic females, 75 Black or Hispanic females in the non-STEM, and then all divided by, we had 300 students plus 500 students. And so what we're going to do is we're going to say it doesn't matter what group you pull them from, it's the same proportion regardless. And so that combined proportion is 87 out of 800, which is 0.10875. So we're going to combine these two pieces together, and then now we're going to do a null hypothesis appropriate approximation of the standard deviation, and this is where we use p hat c for both groups. So imagine 0.10875 is we're saying that it doesn't matter, and so that makes this 0.89125 all divided by 300 plus 0.10875 times 0.89125 all divided by 500. So this is where we're saying, like you can see that we're saying now that there is no difference in proportions. Like it aligns with the null. So if you want to write in here like null, it meets the null hypothesis that we're saying that there is no difference. And so when we go ahead and we calculate that, we get this standard deviation of 0.0227. So what we're saying is that we expect a sample, like we're saying that there is no difference. We expect most of our samples to be a difference of around 0, give or take this 0.0227%, right? Or 2.27%, I should say. So we expect differences in that realm. If we end up with differences that are extreme, more extreme than that, then we're a little bit concerned and we're going to start to think about that. So enough being said about that, let's talk about the general formula. In order to find this, we're going to take our test statistic. So we're going to find that as a z-score. And the way that we're going to do that is we're going to take statistic minus our assumption. So how far off was our sample, our difference in proportions from what was assumed? We assumed no difference, divided by the standard deviation. And so what that looks like as a z-score is it looks like we're going to take p hat 1 minus p hat 2. That was our statistic, the difference in proportions from our samples, minus P sub 1 minus P sub 2, which is nice because it's just 0. We assumed no difference, all divided by the square root of P hat C times 1 minus P hat C all over N sub 1 plus P hat C times 1 minus P hat C all over N sub 2. And so if we go through and we show our work for that, what that looks like is, let's calculate how many standard deviations our difference of negative 0.11 was. Well, we got a difference of negative 0.11. Our null was that there was no difference, so it was 0. The standard deviation was 0.0227, and so we come up with our specific difference of negative 0.11 was 4.8881. 4.881 standard deviations below what's expected if there's no difference. All right, so if there's no difference, imagine if this is my picture, we're saying a normal distribution, 0 and 1, this would be as expected, right? 0 would be as expected. 0 standard deviations away from what's expected would be, okay, it went as expected. We just got a result all the way down here that is 4.8881 standard deviations below what was expected. And so what does that look like as a p-value? So the p-value, now here's where we'd use normal CDF. What's the likelihood of getting a sample like ours, assuming the null is true? Well, the lower is going to be negative 10,000. The upper is going to be negative 4.8881. The mean is going to be 0. The standard deviation 1. It's kind of nice if we do a standardized value that we don't have to put in numbers for those last two things. We just use the default 0 and 1. And we end up with 6.5631184e to the negative 7th. And you would not want to write your answer like that. What you'd probably write it as is 0.0000006 zeros, then 656.31184. Whoops, I wrote 2 8s here. 84. Or really you'd say essentially 0. If the null is true, all right, so if there is no difference, all right, in proportions, they could, proportionally speaking, they're the same, you should not be getting a sample like ours. Like, you don't just get a sample with a difference 11% more in the non-stem versus the stem. Like, that doesn't happen, all right? That's wildly unlikely. So this is where we would say, ooh, certain university, we're in trouble here. We have underrepresentation. We're in trouble. And so what we do then is we go through our three-step process. What's our p-value? Is our p-value less than alpha? Well, is 0 less than 0.05? Yep. This is statistically significant. What does that mean? We reject the null. All right, so we assumed that there was no difference. Our sample has given us convincing evidence that, ooh, there is a difference. All right, there's a difference in these proportions. The separation between stem and non-stem is enough for us to say, like, this is bad. And so we would say something like, we have convincing evidence. And this is where you'd bring back in the context. We have convincing evidence that the difference in proportions, stem versus non-stem, is less than 0, meaning that we have a higher proportion of Black or Hispanic females in the non-stem versus the stem. And so what does that look like on your calculator? On your calculator, you could go through and do that same thing, 2-prop Z test. So on your calc, if you wanted to bypass all that do portion, you would say, I'm going to do a 2-prop Z test. And then it would say, ask you for x sub 1, n sub 1, x sub 2, n sub 2. And then the final piece here would be, is p sub 1 less than p sub 2? So it's kind of a menu here. So we'd say, okay, we got 12 of 300. We got 75 of 500. We'd run that, and then it would give you a z-score. It would tell you how many standard deviations. It would give you a p-value. And then it would give you a p hat c. And so you'd probably want to record each of those things, and that would be affirmation of what we were talking about. So down below, I tried my best to address what does that look like kind of in a generalized form. And then I guess if you had to interpret, is you would say, assuming there is no difference in the proportion of Black or Hispanic females in STEM versus non-STEM programs, there is a probably a 0.00000 whatever probability of getting a sample with a difference in proportions, or getting samples with a difference in proportions of negative 0.11 or more extreme purely by chance. You don't just take a group that has no difference and get a difference like ours. It doesn't work that way, but it's always assuming the null is true. We had to assume something to start. So all that being said, that is chapter 10, section 1. So that's where we're headed, difference in proportions.